Now, if you want to, so now we want to say we don't want to oversample the validate set. So we want the validate set to have the same proportion of positives as the original data. So the original data had what? 0.047 whatever. Okay, so that's the proportion of events in the original data, and we want the same thing, but we do want the remaining 125, okay, that are out of 250, we have put 125 once in the trained data. So the remaining 125 we want to put in the validate data. So minus S1 is going to go into the validation data. Okay. Now we need to figure out how many non-respondents we want. Okay. So add enough non-responses to validate to have the same proportion of responses as the original data. So now we have to figure out how many more. So we're going to do responses, response DF minus S1. So that's going to give us the 125 positive events. Okay, now, how many non-positive events do we need? Okay. Now we have to figure that out. I don't know why it's not here. Okay, let's figure out how we're going to do that. So let's see. So we have in the original so P is the proportion of events in the original data set, right? So now we need to know, so we have n events, okay, and then we want to add x number of non-events so that we get the same proportion as the original data. Okay, so this is that 0.04. That's our n resp over 2. Okay, so how many x's we need so that we get to the same proportion? So you need to work this around. So x then, so n plus x is n over p. Okay, so the number of x's we need is n over p minus n. Right? So we need the p for the original set, okay, and then this n is n resp half, okay, over p minus n resp half. That's going to give us the number of x's we need, all right, so that we maintain the same proportion. Okay, so let's head on out here. And so we need the proportions. Okay, so so let's call it prevalence whole. So that would be, you take the responses, okay, if you find the mean of those responses, okay, so because responses are zeros and ones, so if you find the mean of that column, that's going to give you the proportion of ones. So that's your prevalence of the whole thing. Okay? And then the x we need, so that is n non-response needed, so that's our x, is n resp half over prev dot whole, okay, minus n resp half. So that's the, so n resp half over p minus n resp half. That will give us the number of non-respondents we need. Okay, and then we can generate at random. Okay, you do sample from the non-responses, right? Non-responses, n non-responses, right? N non-responses divided, and then how many we need? N non-responses needed. So that will give us how many we need. Okay, so S3 would be from the non-responses, then you figure out wow. Okay, so there is one thing I forgot to do here, and that would be, okay, we don't want, we've already taken some of the non-responses out in S2, right? So we need the difference. Okay, so that would be remaining non-responses is set difference from so here is okay, we have, that's the original list. Okay, that's the original list, and we need to take away S2 from it. Okay. And then from those remaining non-responses, we select the number we need. Okay. So now S3 now has, from the remaining, okay, from the non-responses, we have already taken out some to put in training. So from the remaining rows, we have now taken enough rows to put in validation set such that we maintain the same proportion as the original. So now we have S3, so we can put all of these together. So we'll say valid 1 dot df, okay, is R bind. Okay. So now that the first part is the remaining positive cases, remaining responses, that's that 125. And then from the non-responses df, we take S3. Okay, now and then let's print it to see. Okay, so prop dot table of, well, I need to put responses here, response valid 1.df response. Okay, so now you see we have added sufficient number of zeros, so the proportion of ones is about the same as the original whole data. So in this case, when you do it this way, your validate data set is not oversampled. Train is. We want that. The validation data set is not oversampled, then we can just simply run the cross validation as we please without having to adjust. Okay? All right? So now if you want to over sample validate also, then it is much more straightforward because we simply need to add the same number of, so we still have the first part the same here. We still pick up all the remaining events. All right. So let's from the non-responses, okay, so we need to sample, we use this, okay. We need exactly the same number as the responses. So that's going to give us the responses. So now we'll call it valid2.df. Okay, and then R bind response minus S1, okay, whatever is left over from the train, and then non-responses, you'll pick up the S4 rows. Okay, and I'm going to copy paste these two lines, and we can see how that valid 2 looks like. Okay, so now you see validate also is oversampled at the same rate as the trained data set.